Welcome back to the GCSE Maths Pro YouTube channel. In today's video, we'll be going through the most common Edexcel questions on probability. So starting out really nicely with question 1, we've been given here obviously Venn diagrams. So they've told us here this little squiggly kind of E looking shape means the universal set. As you can see, it's repeated over here as well. The universal set just basically means what should be inside the whole Venn diagram. So whether that's in the circles, whether that's around the outside, it's basically the contents of the whole rectangle. So in this case, we've been told that the universal set, or all the numbers inside the Venn diagram, are even numbers between 1 and 25. Now, sometimes they list out the numbers that are in the universal set already. In this case, they haven't listed them, so I'm going to actually do that myself so that we can then go through and cross them off. So that would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. Then more specifically, we've got set A has 2, 8, 10, and 14, set B is 6, 8, and 20, and set C is 8, 18, 20, 22. So part A, complete the Venn diagram for this information, 4 marks. So what I normally do is I go along my list of the whole universal set and I just figure out where each number goes. So for example, number 2, that one, as you can see, is just in set A. So I can put it there, cross it off. Number 4 is not in any of the sets, so that would be on the outside. Number 6 is just in B. Number 8 is in all 3, so that will go in the middle. 8, 8, 8. Number 10 is in just A. So over here again. Number 12 isn't in any of them, so that's on the outside. Number 14 is in A as well. 16 is not in any of them. 18 is just in C. 20 is in both B and C, so that would go in the overlap between just B and C there. 22 is just in C. And as you can see, that would leave us with just 24, which is in none of the sets, so on the outside. So make sure, obviously, I know it's kind of easy to figure out what goes inside the sets, inside the circles, but also make sure you're not missing out on the ones that therefore are left over and go on the outside. Okay, part B. A number is chosen at random from the universal set, so from this whole Venn diagram. Find the probability that the number is a member of A, and then this N shape, B. So obviously you have to memorize what the N shape means. This N shape means and. The way I remember that is because the word and has an N in it. The other one is a U shape, which means or. With probability, it's normally and or. So, A and B. What part of the Venn diagram represents A and B? Well, if I highlight it, A and B is technically the overlap, obviously, between A and B. They haven't actually specified whether it doesn't include C, so in this case, we can just assume that it does. So, see here, there's only one number, so that would be your numerator, 1. We can put it as a fraction. Out of, what is it out of? Well, because it was from the universal set, that's out of all of the numbers. So how many numbers did we have in total? There's 12 numbers in total, so that would be 1/12. So you get 2 marks, for basically 1 for each of those numbers, the numerator and the denominator. Okay, question 2. So we've got another Venn diagrams question, however it can actually present itself slightly differently. So the first one was more so set notation, and this one is more of a wordy kind of question that we have to figure out. So, a shop manager wants to advertise special offers on social media platforms. The manager asks 100 customers which of type A, B, or C they use. So, we now need to complete the Venn diagram with all this information here. Of these customers, 4 use all 3 types, so that's quite straightforward. I can just write down the number 4 literally in the middle. Cross that off. 16 do not use any of type A, type B, or type C, so that's also easy, that's just on the outside. Cross that out. 8 use both type A and type B, but not type C. So that's between A and B, over here, but not in the middle, because it's not type C as well. 14 use both type B and type C. Now you might think, oh yeah, that's fine, I can put that here. However, if I undo that, have a look at the previous one. They specified A and B, not C, so I knew that it was here. This one says B and C. It doesn't specify if they don't use A. So I'm going to assume that that means this is 14, because they haven't said that they don't use type A. They haven't mentioned that. So this is where it kind of becomes a trick question. So I think that's 14 in total, which you've already got 4 here. So 14 take away 4 would be 10 for just B and C. Okay, so for these ones you have to be really careful when it's talking about the overlaps. Has it specified just those two, or is it kind of just mentioned those two and not the other one? Hasn't said whether or not it includes the other one. So 62 in total use type A, so we know that whole bubble equals 62, but I'm not really sure about what A and C might be, so I'll hold on to that for a minute. All 20 who use type C, so that's the whole bubble is 20, for C, also use at least one of type A and type B. So that means that there's nothing in just C. That actually the 20 represents these overlaps here. So I can use 20 to work out this final overlap. I know that's 4 and 10, which is 14. 20 minus 14 is 6, so 6 has to go here. So it's just about interpreting what they're saying, basically. Now if I go back to this, 62 in total use type A, that's fine because now I know all the overlaps. The rest will just go in A. So that's obviously 10, 18, 62 minus 18 gives me 44 for just A. So now I've crossed off all this information. That doesn't necessarily mean you're done though, because just double check, does this all add up to 100? So we've got 44 plus 8 plus 6 plus 4 plus 10, and obviously on the outside 16. That adds up to 88. Which bubble have they not mentioned yet? They mentioned, we've already said that we can't have any in C. The only thing missing is just B. We've got the outside, we've got everything else. So you see how that was 88? Obviously 100 minus 88 gives us 12. So therefore, B on its own must be 12. So just double check, once you've ticked off all of these, is there anything missing? Okay, part B. So we've got one of the customers is chosen at random. Given that this customer uses type A, so first of all, what that means is we're just isolating the bubble A. We're just looking at A. We're not looking at the whole Venn diagram anymore like the previous one. We're just looking at A. Given that this customer uses type A, find the probability that this customer also uses type B. So to see how that would be, they haven't mentioned whether they can or can't use type C, so I'm going to include it. In terms of making my fraction, the numerator is going to be those who use B within the whole A circle, so that's 8 plus 4, which is 12 people, out of just the A bubble, because they've said, given that this customer uses type A, it's not out of the whole Venn diagram, it's just out of A. So 44 plus 8 plus 4 plus 6 gives us 62. Now, you can obviously see that that would simplify, but in terms of probability, they don't tend to care if it's simplified or not. So you can simplify it if you want, or just leave it like that. That's absolutely fine. Okay, so the next common question is when we're given a table like this with some values obviously missing. So question 6, there are some counters in the bag. The counters are red, white, blue, or yellow. Bob is going to take at random a counter from the bag. The table shows each of the probabilities that the counter will be blue or will be yellow. There are 18 blue counters in the bag. The probability that the counter Bob takes will be red is twice the probability that the counter will be white. Work out the number of red counters in the bag. So we've kind of got two parts here. This is obviously the sentence here where we're going to use that to help us figure out the probabilities of red and white, and then actually converting that into how many counters there are. So this one could be quite complicated when it says the probability of being red is twice the probability of white. So in this case, I like to use algebra, and I always label X as the smaller probability. So do you see how red is twice white? So white is the smaller probability, isn't it? So I'd put X here. If red is twice probability of white, if red is twice that, that would be 2x, wouldn't it? And then do you see how we can use this to create an equation? What we should know about probabilities is they always add up to 1. So that whole table, red, white, blue, yellow, if I add them together should make 1. And then I've created an equation. And because I've used X for both, not two different letters, I can actually solve it. So that's where I'm going to start. We've got 2x plus x plus 0.45 plus 0.25 is 1. And then you're just solving the equation. So obviously I can add that together to get 3x. I can add together 0.45 and 0.25 to get 0.7, which is 1. And then if I solve that, so 3x, if I take away 0.7 is 0.3. Therefore, x, if we divide by 3 on both sides, is 0.1. So white is 0.1. Now we do need to know red though, don't we? They've asked about red. So I'd therefore have to work out 2x. So 2 times 0.1 is obviously 0.2. So that's red. So I always like to use algebra when I've got this kind of box missing. And it's not necessarily as obvious as the two probabilities are equal. In this case, if they weren't equal, it was a bit harder to figure out. So we've got all our probabilities now. That one is probability of red. This one is probability of white. Now I can look at converting that into actually how many counters have we got. So now I'm looking at the 18. I can create this equation here. 0.45, the probability, is equal to actually 18 counters. You can write it like that, and that's how this is the information I'm going to use because I've got a link between probability and actual number of counters. I tend to use this to work out the total number of counters first, so like 100% if you imagine it that way. The way that we can do this is by, if you think about reverse percentages, obviously probability, they've got it as a decimal here, but that's effectively 45%, isn't it? You should know with reverse percentages, to go from, let's say it says 45% of all the counters is 18, how do I work out 100% of the counters? Well, because it's a calculated question, I can do 18 divided by 0.45, obviously when you're using a calculator, and percentages, they're always decimals anyway, aren't they? So that stays the same. And reverse is because normally we would multiply, wouldn't we? In this case, we're dividing, it's the reverse. And that should give me a bigger number. So on my calculator, 18 divided by 0.45. Do you see how that gives me a bigger number? That's actually now 100%. That's all of the counters. That's the total counters. And then I can go back to saying, right, red is 0.2, or in other words, 20% of all of the counters, isn't it? So I can apply that as a normal percentage in the correct kind of direction. We would normally take the number, multiply it by the decimal. Obviously, you might be able to just figure out what that is, but I'll type it in anyway. Is 8. So there are 8 red counters. Okay, our next question, we've got a probability tree that's half drawn for us, and then a part B question. So Shakir has to complete 2 tests. He can either pass or fail each test. The probability that he will pass the first test is 0.87, which you can see is written here. If he passes the first test, the probability he will pass the second one is 0.94, which goes here. So that's only if he's passed the first one, so it's up here. If he fails the first test, the probability he will pass the second one is 0.73. So that's down here, fail and then pass, 0.73. Obviously they said complete the probability tree with this information. So I filled in that, and then the other 3 fails, we just have to calculate because each of these branches, as in this one, and this one, each of them should add up to 1. So you've got 1 minus 0.87 is obviously 0.13. 1 minus 0.94 is 0.06. 1 minus 0.73 is 0.27. Normally they will only use decimals if it is a calculated question. If it's a non-calculated question, they tend to stick with fractions. So we've completed the tree for 2 marks. Now we have a part B for 3 marks. So work out the probability that Shakir passes at least one of the tests. So now I need to highlight on my tree which options satisfy this sentence. So for example, it said at least one of the tests, he has to pass at least one. So he could pass the first test and then fail the second. Another option is that he fails the first and then passes the second. There's actually a third option though because of the words at least. At least one. So we've got 1 each here. These 2 options are pass, fail, fail, pass. But at least one means that he could actually pass both. Because at least is a minimum of 1, if not more. So he could have 2 passes, pass and pass. Now this is where you figure out what you want to do. You can obviously go through and work out all 3 of these different options individually. Or you can see that the only one missing is fail, fail, isn't it? If you prefer to have fewer calculations to do, you could work out the probability that Shakir fails both times and then subtract that from 1. Because again, all probabilities add up to 1. Fail and fail. You could do that if you prefer. I prefer to just kind of go through in the correct order and just think, I'm just going to work out what I know does satisfy this question. I'm not going to overcomplicate it for myself. But I'm just giving you that option. So let's work out each of these. The yellow one, we have to multiply between branches. When we're working out probability trees, we always multiply between the branches, because when you go along a branch, we're saying pass, or pass and fail. And the and rule means multiply. So obviously we're going to multiply those in our calculator, aren't we? 0.87 multiplied by 0.06 for yellow. For the blue, 0.87 multiplied by 0.94. And for the green, 0.13 multiplied by 0.73. So that first one gives me 0.0522. The second one gives me 0.8178. And finally, my third one gives me 0.0949. Now, because we've got multiple options, only one of these will happen. So when you think about it in your head, it's either the yellow option, or the blue option, or the green option. That's now the OR rule. And in probability, when you've got the OR rule, you have to add. So now we're just going to add these all together. And that gives me 0.9649. That's the probability that he will pass at least one of the tests. So almost 100%. As I said, you could work out just the fail, 0.13 times 0.27, and subtract it from 1, and you should get the exact same answer. If you find that faster, if that makes sense to you, absolutely go for it. Okay, so our last question, question 20. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecaster says there is a 70% chance that it will rain in the village on Monday. Work out an estimate for the probability that it will rain in the village on Wednesday. You must show all your working. So this one's completely blank, but it's kind of laid out in a similar way to the previous one, isn't it? I personally would probably draw a tree. You don't have to, they've not drawn one for you. However, I think I would just like to visualize it. So let's say Monday. Now, for Monday, I'm going to use the probability that the weather forecaster has given. So if we want rain, that would be 0.7 if I put it as a decimal, because all the others are also decimals. Then not rain or no rain would therefore be 0.3, wouldn't it? On from there, we've then got Tuesday. So let's say we follow this branch. It has rained on Monday. The probability of it raining on Tuesday is therefore, based on this original one, 0.8, because it did rain on Monday. Therefore, the chance of it not raining on Tuesday after it does rain on Monday is 0.2. Then down here, let's say it doesn't rain on Monday. So the probability of it raining on Tuesday is then 0.6, and therefore not raining is 0.4. All of these individually should add up to 1. Now, we want to get to Wednesday because that's what they've asked for, isn't it? Probability that it rains on Wednesday. Well, if we're following this branch here, it did rain on Tuesday, didn't it? So that's also 0.8. This one here is therefore also 0.2. We're following this branch. It didn't rain on Tuesday, so it would be 0.6 for Wednesday and 0.4. If we're following this branch, it did rain on Tuesday, so another 0.8 and 0.2. And finally, bring this one down here. If it didn't rain on Tuesday, obviously that's another 0.6 and 0.4. So we've drawn out our probability tree. Now we need to highlight the options that satisfy the question. So it says work out the probability that it will rain in the village on Wednesday. So I need to highlight the ones where it will rain on Wednesday. So it could be rain Monday, rain Tuesday, and rain Wednesday. Option number 2 is rain Monday, not on Tuesday, but yes on Wednesday. Option 3 is not Monday, rain on Tuesday, rain on Wednesday. And finally, option number 4 is not Monday, not Tuesday, but it does rain on Wednesday. So I've actually got 4 things I need to work out. So it's quite a complex tree, this one. So as we did in the previous one, we're just multiplying across. 0.7 times 0.8 times 0.8. Then blue, 0.7 times 0.2 times 0.6. Green, 0.3 times 0.6 times 0.8. And pink, 0.3 times 0.4 times 0.6. So I need to work out all 4 of those. Obviously it is calculator. 0.448 for the yellow, 0.084 for the blue, 0.144 for the green, and 0.072 for the pink. Now again, as before, because these are all different possibilities, they can't all happen, right? Only one of these options can happen. So it's an or situation, this or this or this or this. So therefore we must add them. And that gives me 0.748 at the end. So that's my final answer. That's the probability that it will rain in the village on Wednesday. So thanks for watching this video on the most common Edexcel probability questions. The next video for you to watch is then the hardest Edexcel probability questions. This is obviously if you are looking to get a grade 8 or a grade 9. Feel free to go ahead and have a look at that. If you found this helpful, make sure to like and subscribe, and please leave down below any questions or comments that you might have.